All right. Good morning, ladies and gentlemen. Welcome back to Chemistry 1. I'd like to go through a couple of density demonstrations with you this morning for just a couple of minutes. Take a look at this. I'm holding in my hands, folks, two cubes. They're equal volume, so they're the same size. They take up the same amount of space. The one that's black is made of steel. The one that's shiny is made of aluminum. In my hands, the black steel feels much heavier than the aluminum. Because they're the same volume, I then know that there's more stuff packed into this black cube than this little shiny one right here. In other words, there's the density of this guy right here is higher than the density of this guy right here. Think about that last video. We pictured particles being packed into volume. This has got more particles packed into it than the aluminum one does right there. Well, when we were together in class, last class period, at home, we took some time to make a density column. And I just want to take a moment or two here to come look at a couple of density ideas. Here's a density column that was made in this classroom. Notice we've got four liquids. They've separated themselves out based on their density. The most dense stuff is hanging out at the bottom, and the least dense stuff is floating up here at the top. In this particular example, the most dense fluid is ketchup, followed by milk of magnesia, followed by a purple dish soap, followed by a vegetable oil. Okay? Most dense stuff at the bottom, least dense stuff up at the top. Check this out. Here I have two beakers. One of them, I'm going to change my camera view here a little bit. Sorry. There we go. One of them I've dyed green, and the other one I've left clear. One of them is water, and the other one is isopropyl alcohol, or rubbing alcohol. Okay, you can buy it at your local, pharmacy, your grocery store, Walmart, etc. It's just rubbing alcohol. Watch what happens when I put a piece of ice into the green fluid. Okay, it floats. Oh, interesting. So that means that ice is less dense than this green fluid that you see right here. Watch what happens when I put some ice into the clear stuff. Oh, kind of hard to see on the camera, but definitely visible. Watch when I drop it in. It goes straight to the bottom. So ice is more dense than that clear stuff. Now, in your brain right now, think about what happens to ice when you put it in a glass of water at home. Does it float or does it sink? If you said ice sinks, you've made the correct call. So we've got green water, dyed with some food coloring, and ice is less dense than the water. And I've got clear isopropyl alcohol. Ice is more dense than isopropyl alcohol. That means I can pour these into a density column. So here I've got an empty graduated cylinder. Okay, I can pour in the water first. It's green. Let's go ahead and pour some in. There it is. Ooh, not even St. Patty's Day, but there we go. Some green water. Okay, and now I should be able to pour the isopropyl alcohol on top if I pour carefully. Let's see if I can handle that this morning. Got to be poured slowly and carefully, which is what I'm doing right now. See if we can't get a clear layer of alcohol to sit on top of the green dyed water. And go a little bit longer here. Kind of see that alcohol streaming down the inside of the graduated cylinder. And you notice there's definitely a darker green at the bottom of the cylinder compared to the top. And if I stand them up, voila, I have a pretty nice, maybe if I put this behind it, that's somewhat better in terms of viewing. You can see a clear layer right here of isopropyl alcohol and a darker down below. Water is more dense than isopropyl alcohol. In other words, more mass packed into volume than you have up here. And if I grab a chunk of ice or a couple of pieces of ice and place them into the graduated cylinder, we should be able to predict where it will end up, because ice floated in water and sank in isopropyl. And so my two pieces of ice, there they are. You can see them on the screen pretty darn clearly. They're just kind of hanging out. Here they are, right there in the middle, in between the interface, we call it, between water, which is green, and alcohol, which is clear. So matter can separate itself out based on differences in density. And that can happen not only with liquids, but also with solids, and also, ladies and gentlemen, with gases. Let's move our camera over here to this fish tank. And you may be able to tell at home, I'm not 100% sure if you can, but there is a white powdery substance. There it is. Oh, yeah. There's a white powdery substance in the bottom of this fish tank this morning. That is sodium bicarbonate, which is just a fancy way of saying baking soda. What I'm going to do this morning, folks, is add another common household ingredient, vinagre, to the baking soda. When you do that, a chemical reaction occurs in which carbon dioxide gas is produced. You'll notice it because there's going to be a whole bunch of bubbling. Okay, let's make some CO2. Here we go. Oh, look at that stuff foam. Yeah. As those bubbles pop, the tank fills with carbon dioxide gas. I'm going to try to blow some bubbles in there. What you can see on camera are some bubbles floating in the middle of the tank. They're floating on an invisible layer of carbon dioxide. The bottom of the tank right now, right down here, is filled with CO2. And it's more dense than some of the air coming out of my lungs right now. And so you got this cool bubble right here. Look at this. It's like a rubber ducky in your bathtub. It's just floating around on that surface of carbon dioxide. So this is an observation to show us that gases have different densities too. And carbon dioxide happens to be more dense than the air in this room right now. Of course, we're all familiar with gases that are less dense than the air in this room. There's my helium balloon from a couple of days ago, still floating, right? The particles of helium in this balloon are spread way out. It's got a super low density, and that's what makes the balloon want to go up. I've got one more demonstration for you this morning. I'm going to come back over this way to my lab table. Let's go down to there. There we go. We can see the table. I'm going to move a couple things out of the way. Give me a sec. By the way, you can still see there's a chunk of ice right there. Oh, beauty. Floating in between the water and the alcohol layer. That's cool. I'm going to reach back here this morning and grab me a candle. How about this one? That looks good. A nice little pink candle. And I'm going to light it with a lighter. There we go. And so it's lit. I don't know how well that's showing. I'm going to come a little bit closer with my camera and see if that's better. Hopefully I don't burn the candle. There we go. So I've got my candle burning away. Meanwhile, maybe I don't want to go there yet. Sorry. Meanwhile, in this pitcher, I am going to produce some carbon dioxide gas. Okay, I'm going to do it the same way I did it before. I've got some powder in there. That's nothing more than baking soda. I'm going to add some vinegar. It's going to fizz. I'm going to get a bunch of carbon dioxide. Now, the carbon dioxide should stay in the bottom of my pitcher. And it's more dense than the air in this room. So watch what I'm going to do. I'm going to pour the pitcher of carbon dioxide out onto the candle to extinguish it. Ah, Now, you couldn't see that real well, so let me move my camera back a little bit so you got a better vantage point of me actually pouring the the carbon dioxide out of my pitcher. This is no trick, ladies and gentlemen. Carbon dioxide is heavier than air, more dense than air, so it's going to come out of the pitcher just like water. It's going to put the candle flame out. Just watch. And there it goes. It's so neat looking because carbon dioxide is colorless and odorless. You can't see it happening, and yet here I am pouring a pitcher of a gas that's heavier than air to extinguish the candle. Of course, to keep the candle burning, you need oxygen because burning or combustion is a chemical reaction between oxygen and the candle wick. By pouring the carbon dioxide onto the candle, I'm not letting oxygen get there. And out it goes. That, ladies and gentlemen, is pretty darn nifty and pretty darn fantastic. There you have it, ladies and gentlemen, a few demonstrations of density. Remember, density is a measurement of how packed together the atoms or the molecules, sometimes we just say particles of a substance are. And we've seen firsthand, now we have great experience to show us that more dense things go to the bottom, less dense things go to the top. And that's true not only for liquids, but also for gases and solids and liquids. If you have any questions on these ideas or you need to see a demonstration again, just rewind the tape, scratch that. This is 2020, you don't need to rewind it. You can just go back and watch it again. Until next time, ladies and gentlemen, have a wonderful day. Adios.